Okay, so this is a video to help you with step assignment number 4, the actual step question. Not going to bother with the prep or the warm-up or anything. Here's the question, let's get straight into it. So the first bit, find when this cubic is greater than or equal to 0. Now I'm thinking two things immediately. First thing I'm thinking is I need a sketch. And the second thing I'm thinking is I need the roots. So I need the roots and I need a sketch. So how do I find the roots of a cubic though? Well, I could use the root cubic formula, but I don't want to die. So what I'm going to do instead is I'm going to use the factor theorem, which is f of a equals 0, then x minus a as a factor. So essentially what I'm going to do is I'm just going to trial and error until I find a root. I'm just going to try random stuff until I find a root, something that works, something that makes this work. I can try 0, f of 0. If I put 0 into here, all of these go away and I'm just left with 4, so that's not going to work. If I try f of 1, if I put a 1 into here, I get 1 cubed minus 4 times 1 squared minus 1 plus 4, and that does equal 0. So 1 is a root, and from the factor theorem, x minus 1 is a factor. So this cubic here factors out into x minus 1 times some quadratic. I know that because 1 is a root. And I found my first root, I can find the other two later. And this is how I'm going to do it. So you could do some polynomial division here. Lots of you will be comfortable with that. But what I'm going to do is I'm going to notice, well, hang on, look at these last terms of this side. That's a 4. The last term of this side is a minus 1 times b. Therefore, minus 1 times b is 4 and b is minus 4. And I can get what b is straight away. Now, if I just expand this out just quickly, x cubed minus x squared plus ax squared and so on, and then I just look at the coefficients of x. Over here I have a minus 1, and over here I have a minus a minus 4. So therefore minus 1 equals minus a minus 4, and a is minus 3, I think. And so this is my factored cubic into a linear and a quadratic. I can do even better than that, and at this point I'll get my axis down because I'm ready to sketch, almost. I'm going to take this quadratic here, and I'm going to factorize that, because I can, easily. And what this is saying is I have that root at 1, which I found by trial and error. That's the root at 1. I have a root at minus 1, which goes here, and I have a root at 4, which goes there. And even more than that, I also have my y-intercept, because earlier, remember when I was trying values, I tried f of 0, and now the y-intercept is when x is 0, right? Because there's no horizontal movement when you're on the y-axis. And when you put in x as 0, you get y as 4. So the y-coordinate is 4, and the curve you can put through this looks like that. And now we have to say is, well, when is this curve greater than 0? Well, it's clearly greater than 0 between minus 1 and 1, when it's above the line here, and when it's greater than or equal to 4. Right, that's when it's all above 0. And that's the answer to part 1. Now, part 2 looks horrific, but it's doing the classic step thing, which is it's testing, can you notice how closely related this new question they're giving you is to the old one that they just gave you? Can you notice how closely this thing looks like this thing? And it's basically the same object, except they've stuck in increasing amounts of y into the last 3 terms. And what you have to notice here is that, okay, if I can factorize this function into this, like I just did, then that means I can factorize this function with all the y's into this, just with a few more y's put down. And now I haven't got a function, I've got the thing equal to 0, so I'm going to replace that with 0, and I'm also going to tidy up these 1's. Here, but this is my factorized quadratic weird function here with x's and y's. This is what it is. But this is cool, right? Because these are 3 things that are multiplying to make 0. The only way to multiply stuff to make 0 is to have at least one of them be 0. So either x minus y is 0, or x minus 4y is 0, or x plus y is 0. But I can rearrange these now, right? Add y to both sides, add 4y to both sides divided by 4, take away x from both sides, and these are just lines. In fact, these are these 3 lines. Y equals x is this line, y equals a quarter x is this line, y equals minus x is this line. So those are the 3 lines that do this. And if you just type this into a graphing calculator, this is exactly what you get. So the third part of the question then, so I've got my sketch down, these are my 3 lines. Now shade the regions. So this is my sketch, I'm going to start shading regions on this sketch for which this is true. Now, there are 2 ways to do this. You can either do this in a beautiful, mathematically logical way, which I'm going to do first, or you can do it in a very cheap way, which I'm going to do second. So the beautiful way is to factorize this out into the 3 terms that we already know it is, because we did that in the first bit. And then to say, well, hang on, there are 3 things that are multiplying here to make something greater than 0. Now, there are only 2 ways to do that. You either have all 3 things be positive, that would make it work, or you have precisely 2 things to be negative and 1 to be positive, because then the two negatives will cancel and you'll be left with a positive. And we just need to run through those cases. So the all positive case, where this thing is positive, this thing is positive, I should say greater than or equal to 0, I guess, but whatever, and this thing is positive. Now we rearrange those to make this, move the 4y over to make this, move the minus x over to make, take away x from both sides to make this, and now we just look in the sketch, where are all three of these things? Where is y less than or equal to x? Well, this is y equals to x. When is y less than or equal to x? Well, that's below this line. So I'm looking below this line. When is 4y less than or equal to x? Now, I've written it differently to hit here, but that's okay. Y less than or equal to x over 4 is below this line. So I'm looking for below this line and below this line. And y greater than minus x, so that's above this line. So below this, above this, well, that's this region here, right? That's the region that's satisfied by the all positive case. Let's just double check a point. Let's check the point 2, 0, put it into the original function. Now this is good, right? I've chosen 0 because that means all the y's just go away, and I'm just left with 2 squared, which is 8, which is good. So this is definitely correct. I haven't made a mistake here. So that's one correct thing. Now let's go to the next case where I've got two negatives and a positive. Let's go with the first two brackets being negative first, and then this being positive. So this negative, this positive. Two negatives multiplying by another positive will make a positive because the two negatives cancel. Now let's rearrange these, add y to both sides, add 4y to both sides, take away x. Now we're looking for y to be greater or equal to x. That's above this line. Y greater or equal to x. We're looking for 4y to be greater or equal to x. That's above this line as well. Above that one, because the y is the bigger one. And we're looking for y to be greater than minus x. So we're looking to be above this line, and this line. Well, that's this region up here, right? That's the only region that's above every line. Check a point. Check the point 0, 1. Again, I've chosen 0 because that means all the x's this time go away. And I'm just left with 4 times 1 cubed, which is 4, which is good. So this is correct. Next case. Let's do this negative, this positive, this negative. So that negative, that positive, that negative. Rearrange by just moving them over, and then just which region is this? Y is greater than or equal to x. That's above this line. Y greater than x. That's above that line. 4y or y less than or equal to x over 4. So that's below this line. So we need to be above this line, below this line. Well, only one region does that, is this one. So let's just double check it's okay with this. Y less than or equal to minus x below this line, that's fine. This is good. This region is the one. So this one here. And if you wanted to, you could check that point. That's going to be more annoying to check because you don't get rid of one things immediately, but it does work out. So that's this region here. Excellent. Only one more to do, which is the middle case and the last case negative. So positive, negative, negative. That was my last case. Rearrange those, obviously add y, add 4y, take away x, on the same thing every time. So I'm looking for y to be less than or equal to x. So less than this line, underneath this line, I should say. I'm looking to be above this line. So I'm looking to be underneath this line and yet above this line. Well, that only leaves this thing up here. And I'm looking to be below, y less than, below this line, which doesn't work for this. So nothing here will work for these three cases. So there are no cases, there's no area that is satisfied by all three of these. So I just don't put anything down. And so this is my sketch. This is my completed sketch. I've gone through all my cases. One of them didn't work at all, but the other three did. They gave me these three things. So that's my sketch. That's everything skated in. And I'd blow the examiner's mind. That's such good maths. Anyway, there is a cheap way of doing this question, which is go back to the start and just pick a point in each area. So let's pick minus 3, 0 to start with. Put that into here, obviously choosing 0 to make all the y's go away. Minus 3 cubed is minus 27, which is less than 0. So this is not a region I want to sketch. Then I move over to, let's say, this region. Check 1, 0. I'm obviously choosing 0 because all the y's go away. And I get 1. So this is a region I want to sketch. And then I would check this point, and then I would check this point, and this point, and this point, and I would just shade the ones that are above or equal to 0. Now, obviously, it's probably a quicker way of doing it, but I really liked the logical way that I did it first. But yeah, that's kind of how you do that set question.